Welcome to my talk on scientific notation, and for today we're just going to give a brief definition and a few examples. Scientific notation is really based on powers of 10, and it's usually just some way of not only stating the value of a number, but also outlining how many significant digits a number has, but we will not talk about significant digits today, but just about the notation itself, and give several examples. So, 1 is 1 times 10 to the 0. 10 would be 1 times 10, right? Or 1 times 10 to the 1. For the two numbers in question that you see on display here, notice that 4.36 times 10 to the minus 5 is given to represent 0.0000436. The 4 is the most significant digit. The numbers that come before it are all zeros, and those zeros, called leading zeros, are usually ignored. In the second example, we have 4.36 million. Well, it's a little easier to tell that the number 4 is 4 million, that being the determining factor, the overwhelming determining factor of the value of the whole number, followed by the digits 3, 6 again. So we once again have 4.36, but this time we ignore the trailing zeros, and once again 4 is the most significant digit. Now, if the exponent is negative, you ignore the leading zeros. That's the general rule. So 4.36 times 10 to the minus 5, you're ignoring leading zeros. If the exponent is positive, you ignore the trailing zeros, especially if not followed by a decimal point. Usually it's customary to give the number followed by an exponent. So 357 would be 3.57 times 10 squared. So, it's like 3 times 100 plus 50 times 10 plus 7 times 1, if you like to think of it that way. 0.1 decimals can be given scientific notation. So 0.1 is 10 to the minus 1, 0.01 is 10 to the minus 2, and so on. 0.000357 would be 3.57 times 10 to the minus, now what? Let's count. 1, 2, 3, 4, 5. 10 to the minus 5. You just count your zeros, including the first digit. So that's how you do that one. And let's do another one. Let's do 254, and let's see, bunch of zeros, just a bunch of zeros. Okay. And let's put some commas in there, starting from the end to figure out what kind of a number I've got. 25,400,000. Okay. So 2.54 are the only numbers that are not zeros in there. The rest of the zeros are considered not significant unless followed by a decimal point. Now 2.54 times 10 to the, now I just count all the digits up to the leading 2, and I count 7 digits. So 2.54 times 10 to the minus 7. Now, eventually, anything with a value, any real number, can be eventually expressed as a scientific notation, including fractions. So like 1/3 can be 0.33 repeating, which can be approximately equal to 3.3 times 10 to the minus 1. Similarly, 1/2 would be exactly 5 times 10 to the minus 1. 1/12, I looked it up on my calculator, and my calculator told me 0.0833 repeating, and so that's approximately equal to 8.33 times 10 to the minus 2. In fact, using estimation, any real number ultimately can be expressed in scientific notation.